Everyone, it's Mr. N here with your next lesson. So your last lesson should have explored functions a little bit. This one we're actually going to talk about some of the trigonometry that's introduced in the problem sets for 1.1.4. So lesson 2 is just going to be some basic trigonometry review. We did touch on this a tiny bit during geometry, but that was a few years ago, so I figured it would be good to not only explain why we need it, so remember our objective here. What is trig? What is trigonometry? And our second one is how do we use it? And this is really going to help out with a few of the homework problems, so I'll go over one of those in addition to this. So let's start off with the first one. Trigonometry has to do with the study of triangles. Particularly, it has to deal with the study of right triangles with a right angle, a 90-degree angle. So, if we have something such as an angle, so we represent it by this symbol, the Greek symbol theta. I'm actually going to rewrite that in a different color because orange is not working out for us. So let's see if we can get a darker red in there. That looks a little bit better. So this value here is theta. You may have seen it before, but it just represents the angle for that vertex. Okay, so throwing a little bit of geometric terms at you, but just remember every time you see that value, it is the angle. So, if we're looking at trigonometry, we're looking at this angle and trying to figure out, well, what is some of my values, A, B, and C here? Oops, again, a little too light. So let's make that a little bit better. Get a darker one. A, B, and C. So we have these three different sides, A, B, and C, and we can connect it to this angle theta right here in terms of some special functions. So these functions are sine, cosine, and tangent. So let me redraw. So trigonometry relates a right triangle's angles to its sides. So if we have all three sides, we can get that angle. And what you'll find is that if we have this angle in just one of our sides, we can actually find the other two sides. So what I'm going to do here is actually redraw this to be very general. So we have our right triangle again. We have our angle theta. And we want to talk about the different parts of these, the different sides of these triangles. Or not these triangles, of this triangle. So first we need to look at the three sides. We have the side opposite is conveniently called opposite. The side adjacent, or right next to our angle, is going to be the adjacent side. And finally, this long side, you guys know this one. We've talked about it a ton. It is the hypotenuse. If you're ever unsure about which one's the hypotenuse and which one's the adjacent side, because they're both right next to that angle, think about the side that's opposite of your right angle. So opposite of right angle. Okay. So that's basically what trigonometry is. It's relating this angle theta to our opposite side, our hypotenuse, or our adjacent side. Okay, so what we need to do now is kind of figure out what these symbols are, or what these equations are, and how we use them. So, if we want to relate two of these three together, there's actually 6 different ways. What we're going to do here is actually focus on 3 of those 6 ways. One is going to be the ratio between the opposite and the hypotenuse. One is going to be the ratio between the adjacent and the hypotenuse, and the last one is the opposite over the adjacent. So what I'm going to do is write down some equations for you, and we're going to go step by step through them. So our first one is the sine. So the sine of our angle is equal to the opposite side divided by the hypotenuse. And so we can move on and say, okay, well, what about the adjacent over the hypotenuse? Well, if we want to take the ratio between our adjacent side and our hypotenuse side and relate it to this angle, we're going to do it through the cosine function. And finally, the last one I told you we were going to discuss is the tangent function. So that's where our last ratio comes in, the opposite over the adjacent. So that is going to be the tangent of our angle, okay? So we have the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent, okay? So we're going to have one little shortcut to remember this, a little mnemonic, and we call it SOHCAHTOA. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. Oops. Over the hypotenuse. And then the tangent is the opposite over the adjacent. So if you're ever unsure which ratio you want to connect to which trig function, just remember SOHCAHTOA. You can even box this thing. Remember that this all is going to be important tools that we're going to be using in the future, very near future. So I'm going to run through 2 examples. One is really figuring out what this means in terms of numbers instead of just values. The second thing we're going to do is actually use this to figure out one of our homework problems. So let's start off with just a general example. We have a right triangle. And we have a mystery angle that we want to relate to these ratio, or to our sides of our triangle, which have the dimensions 3, 4, and 5. So the first thing you want to do, and maybe you want to pause the video to try this out yourself, is figure out what's the adjacent side, what's the opposite side, and what's the hypotenuse. So if you tried this out, what you'll find is the adjacent side is going to be equal to 3. The opposite side is going to be equal to 4. And 5 is going to be our familiar hypotenuse. So from here we can ask, well, how do we write our 3 trigonometric functions? Gonna squeeze it in there. Functions to this triangle's sides. So we first got to look at each one individually. We want to first check out sine and say, hey, if we want to figure out the sine of our angle, the sine of theta, that's going to be equal to the opposite over the hypotenuse. Well, we know the opposite side here is equal to 4, and the hypotenuse is equal to 5. So that's all there is to it. We're just trying to say, if I have an angle and I'm trying to relate it to the ratio of the opposite side and the hypotenuse side, it's actually going to be the sine of theta. So we can continue going through this. We have the cosine of theta. Cosine of theta. And that's just going to be equal to the adjacent side over the hypotenuse side. So our adjacent right here we'll see is 3. So 3 is going to be in our numerator, and then hypotenuse is still equal to 5. So we have the cosine of theta is equal to 3 over 5. We did it. We talked about our cosine in terms of the triangle's adjacent side over its hypotenuse. And so finally we have our tangent of theta. And so remember that is tangent of theta. And so that's going to be the ratio between the opposite side and the adjacent side. Well, our opposite side is 4. Put that in the numerator. And our adjacent side is equal to 3. So the tangent of theta is equal to 4 over 3. Box that up, and we have our 3 answers to our questions, how we write 3 trigonometric functions to this triangle's sides. Okay, so now that we're kind of familiar with how to relate each other, we're going to talk about how to actually use these to compute missing sides, which is what actually 139 in your homework is asking you to do. So let's check that out. For part A, 139 part A, we are going to solve for x. So first thing I want to do when I try this out is draw out my right triangle. Something like that. We know that this angle right here is 26 degrees. We know that we have a value of 18 up here, and we have a value of x down here. So when we're doing this, we might want to think about, well, what's relevant here? And before we can even answer that, we might as well figure out what we have, what we don't in terms of these triangle sides. So if we're looking at our triangle, we know that we go opposite to the angle that we are given, and that is going to be our opposite side. So this is going to be O. And we have to remember, we don't know this. It wasn't given to us. There's nothing talking about this O. So that's a good hint that we might not need to have this O in terms of our problem. So we go through it, you realize, hey, I know this is the hypotenuse because it's opposite to our right angle, so we might as well label that H. And now we're finally looking at the x. This is what we want to know, what we're trying to find. So that's certainly relevant. We might not know it now, but our goal is to eventually know that thing. So we have our hypotenuse, we have our opposite. We know that this x is going to be the adjacent side, or the side right next to our angle. So we can just say that a is equal to x here. And then finally, we know that our 26 degrees is our theta. So next we want to see what is relevant here. We know we don't know the sign, or we don't know the opposite side. So what we can do here is say that, let's just rewrite our SOHCAHTOA. SOHCAHTOA. And what we really want here is just every instance. Let me get another color going here. Oh, let's go with this gold color. TOA. Okay. So we want to figure out which one will give us all the different parts. So if we're looking at this, we know that our O, our opposite side, we don't know that. So anytime we see an O in here, we know that function is not going to help us out. So sine is opposite over hypotenuse. We have we don't know the opposite, we can't use that. TOA, tan is opposite over adjacent. We don't have our O, so we don't know that. But what we do have is that our A is 18. Whoops, our A is X. And our hypotenuse is 18. So we know that if we want to really find this missing value x, we're going to have to use the cosine function because it's giving us our angle, it's given us a hypotenuse, and it's told us we're looking for the adjacent side, or x. So if we rewrite ka, so this one's the one we're going to use, it's going to be the cosine of our angle is equal to the adjacent side over the hypotenuse. So what we want to do here is just plug things in, and then we'll deal with what this cosine means, how to calculate all of that. So I substitute my angle theta with what it represents. So here it's equal to 26 degrees. And we know that that's equal to the ratio between our adjacent side, which is x, and our hypotenuse, which is equal to 18. So we're looking for this x. This is a number. We're going to calculate it very soon. But first we want to get our x alone, and it's the same way we do it in any other case. So if I'm looking at our x over 18, go ahead and take a second, think about what you might have to do to this side and thus both sides in order to get the x alone. Okay. So if you guessed multiplying by 18, you're definitely right. X divided by 18 times 18, these two cancel, but we also know we have to multiply both sides by this. So I'm going to switch this around so it's a little more clear, and I'm going to convert to one color, where x is equal to 18 times the cosine of 26 degrees. So we're so close. We just need to figure out what this cosine of 26 degrees is. So this is where our calculator comes in. This isn't something that we really can tell, we can numerically calculate. This is a calculator problem at this point. And you'll notice, I'm going to show this right up close. Every single calculator has these functions. We have a sine, a cosine, and a tangent. And we have some secondary ones that we'll eventually get to as well. So if we turn on our calculator, and we press the cosine, notice how you get the cos and an open parentheses. So if you want to calculate the cosine of 26 degrees, it's just a matter of writing in that angle and closing the parentheses. So it turns out the ratio between our adjacent side and our hypotenuse side is about 0.89, or the adjacent side is 9/10 the length of our hypotenuse. So notice what I'm saying here. The cosine is giving us the ratio, or comparing how long our adjacent side is to our hypotenuse. So if we know the hypotenuse and we know the ratio through the cosine, we can use that in order to figure out this missing value. So let's do that. We had that the cosine of 26 degrees was equal to 0.89. So you can verify. So I'm actually going to round that up to 0.9. So 18 times 0.9. And so that, when I plug it in, 18 times 0.9, we have 16.2. So it turns out that mystery value x is 16.2. So let's rephrase what we did here. We're given the hypotenuse, given the adjacent, knowing we're trying to find it, given the angle, we know that the opposite side here, once we labeled everything, it just wasn't relevant. We're not looking for it, we don't have any information, so we know we do not need the opposite side to solve for x. So we go through our SOHCAHTOA. We notice sine is opposite over hypotenuse, don't have that opposite, cancel it. Same with tan, cancel it. So we have the cosine equal to adjacent over hypotenuse. After putting in our values, we know that x and 18 are going to be our sides for the ratio, or our values for the ratio, and it's equal to cosine of 26. We solve for x, know that we can use our calculator here in order to simplify this to about 0.9, calculate it out, get an x value equal to 16.2. So hopefully this helps out a little bit. I know this ran a little bit long, but I think there's a lot of ideas that come in full force. So yeah, just in case you were trying at those last problem sets in that last problem and weren't sure about what to do with it.